Running.
Okay, hi, welcome to Mathematics with Tom. I am Tom, and today we are going to learn to graph in 3 dimensions. Here we go. It begins with a vertical line. I think that's the easiest way to start, and leave yourself plenty of space here. So I'm going to make a vertical line about that long. Now we're going to make a horizontal line to the right that's perpendicular to our vertical line and ideally the same length. So here we go. Here's my horizontal line perpendicular to my vertical line and about the same length. Okay, then we're going to make a third line. The third line, these 3 lines will be the foundation for our whole picture. The third line will come off of our corner at about 45 degrees. It doesn't have to be perfect, but what it should be is it should be the same length as my other 2 lines. So in this case, I need to make my line a little longer. Now, what you don't see is, remember, this is a 2-dimensional surface in which we're representing a 3-dimensional object. So there is distortion. And here's where the distortion is. This first line, these first 2 lines were 90 degrees to each other. But in order to show the third surface, these lines here are also perpendicular to each other. And the vertical line and the slanted line are also perpendicular to each other. So everything in here is perpendicular to each other. With that in mind, let's finish drawing. Now, we're going to do what's called drawing through the cube. We're going to construct a cube, and we're going to actually imagine that we can see through the cube. So I'm going to draw my cube in this orange, and it's coming off of the board towards me. These are my foundational lines. And let's label them right now. This horizontal line that we drew, this is my y-axis. The line coming off at an angle represents the x-axis. The vertical line represents the z-axis. Okay, from here, what we do is now we start making parallel lines. I need a parallel line from the top of my z out to the y, and then I need a parallel line from here with the z. So, whoops, I'm going to do this in orange. So I need a line that's going to come up, and I need a line that's going to come over to make a square. Now that's the easiest part of the whole picture. From here, we need to make a square with the z and x, but this one's at an angle. So what I want to do, I'm going to check my distance again, reference it. So I need to draw a vertical line from here to about there. Then I want to connect my z to this one, and really that is, even though it's being drawn at a slant, that's another square. So I've got this square here. You can tell it's not perfect. If you have a ruler, that might make your picture a little better. We're going to draw now another line of the same distance. This time it's going to be parallel to y. And now we're going to draw one more parallel to x from the y. We're almost done. Imagine this is a box with 1, 2, 3 sides. So we're looking into the box. You could set something in there. From here, to close the box up, what we do is we need to draw a vertical line from this corner, up, and it'll be the same height as all of our other vertical lines. So I draw a vertical line. And now I connect. I connect the horizontal line, and I connect the slanted line. And now I have a cube. I want to take a look closer at this cube and label the points. So if I was to label the points, this is my x-axis. So when I'm at this point right here, this is the point of x is 1. Notice that we haven't traveled along the y-axis, so that's, let me put this down below. Let's get it kind of messy. So this is the point, x is 1. We haven't gone out on the y-axis, that's 0. And we haven't gone up on the z, so that is also 0. And again, this is my x-axis. I'll put that label up here. There's my x-axis. Okay. Now, if I travel just along the y-axis, then this point here has x is 0, y is 1, and we're not going up at all, so z is 0. Now, if I don't go out along the slant, I don't go to the right, and I just go straight up, then I have the point where x was 0, y is 0, and z is 1. Now, we've got 3 of our corners. We have a few more, 3 more. So now let's go where x is 1, and then I'm going to go up. Well, when I travel up, that is a z value. So this point here becomes x was 1. Notice I didn't slide out to the right, so y was 0, z is 1. That's this point here. Then let's try this one in this upper corner. Notice I don't want to come out x at all. I need to slide over on y. I need to go up, so that's z. So this is the point 0, 1, 1. And let's see, we have 2 more points to label. Let's come out x. Let's slide horizontally, so that's y. But then we don't need to go up. That's the point 1, 1, 0. Finally, my last point is if I come out on x, slide over on y, rise up by z, that takes me to this point right there. But this time I'm not going to label it as a point. Let's label it as the vector. The vector, and what vector would that be? That is the vector of 1 for x, 1 for y, and 1 for z. So I would label this using my vector notation, and not only that, but I'm going to draw that vector. That vector begins at the origin and goes up to that point, and so that is the vector 1, 1, 1. Get it? Okay. A little bit more. Oh yeah, good. And, all right, so we have another one. Right here, this is where we have 0, we don't go out on the x, we don't slide out for y, we don't rise for z, so the origin is the point, the origin, I'll write it over here so I don't get too cluttered. The origin in this case is not just 0, it's x is 0, y is 0, z is 0. Okay, now let's take a look at what we have. If we stay just in this region of the bottom of the box, like where you might set something, if you were going to put something in the box, it would rest on the bottom. This region here, I'm going to try to shade it in for you, in this pretty pink color. This pretty pink is the XY plane. Now, it's the XY plane, is right there. Now, what people mistake is that this is a 3-dimensional picture. We're in R3. And a common mistake I hear is when we refer to the XY plane in R3, people will say R2. If my picture was only X and Y, then we'd be in R2. But we're not. This is the XY plane in R3. Okay? And we know we're in R3 because all of our points have 3 elements or 3 components. The next plane is the back of the box. It's actually the chalkboard itself, or your piece of paper on which you're writing. That's this region back here. So this green region back here is where x is 0 all of the time, and all of our values that are non-zero or 0 is in this region here. This is the y, z plane. And let's make a note, and I'll go back. And in the y-z plane, all x values are 0. And in the xy plane, all of the z values are 0. That leaves us with one more plane. And that's this one right here. This left side of the cube. This left side of the cube here. Let's smooth that out. Remember, you're looking through the box, back into its corners. So that blue panel there, now notice here, we have values for x, and we rise up, so we have values for z, but we never slide off. So in this case, this is the xz plane. And in the xz plane, all of our y values are 0. Okay? That's the basis for how you draw in 3 dimensions. So we're going to do one example. Let's try this. We're going to come over here and we're going to create a new picture so we can practice what we've learned. Let's practice what we've learned over here. And I'll probably need some colors as well. Let me grab a couple beautiful colored chalk. Over here. And what we're going to do, our goal here is to do this. We are going to graph or sketch the vectors. We'll call it x, and let's graph the vector 1, 2, 2. There we go. We're going to graph or sketch the vector 1, 2, 2. And here's how you do it. Let's start with a vertical line, just like we did last time. But this time, we're going to go big. That's the z-axis. Now, let's make our horizontal line. And again, I'm going to go pretty big with this. That's my y-axis. And then we have our slanted one that comes off of our corner. This is the x-axis. And again, remember, just for peace of mind, y and z are perpendicular, z and x are perpendicular, and x and y are perpendicular. Now, let's mark these off. Let's draw our first cube. I'm going to use the same dimensions here. So let's make this, there's my 1, 2, let's go 3 units that way. Probably don't need that many, but 3 will work. 1, 2, well, that's enough in that direction. And 1, 2, 3 in that direction. Okay, so I've given myself plenty of space. I'm going to put my tick marks. My tick marks on the x-axis might look like that. My tick marks on the y-axis would probably really be something like this, where these lines are parallel. And my tick marks on the z-axis might look like this. So you'll be able to expedite this process with practice, but let's just go back to the most simple way of doing this. And it starts with the first cube. So let's draw our first cube. We have our foundation, our x, y, and z axis. So I'm going to make each cube in a different color so we can see. So our cube began. We're going to come over. We're going to go up. We're going to come down and go up. You can always overshoot them, and where they intersect is the point of interest. Let's come parallel this way and parallel this way. Now, we need to start from these corners. We're going to go horizontal and vertical. And there is my first cube. There's my first cube. Well, let's look at what we have and what we need. We have x is 1. Well, x is 1. That we've got. That occurs right here. There's 1. But what happens about y is 2? Well, y is 2. That's way over here. And z is 2. That's up here. So what we need to do in order to finish our drawing is we need to stack some cubes. So let's make some more cubes. We're going to start, we're going to get out here to where y is 2, and then let's see where we're at with regards to what we need for z. So I'm going to make another cube, and I'm going to do that by continuing my line over. I just continue all of these lines. Now I'm going to bring this 2 up to the back line. Bring this 2 out to the front. And then we're going to bring this up to the green line and match it over. Now look, now we can come out to 1, we can slide across to 2, but we can only go up to 1 for our z. So what do we need? We need another set of cubes. So let's draw that. Let's draw another set of cubes. Pink is a good color for the next set. So we just continue our pattern. So let's bring this line up. We're going to meet a horizontal line, or a parallel. And then let's bring this across. Bring our z up, or there. Let's bring this intersection across. Let's bring this line up. What do we, oh, we need to connect here. Let's bring this line up. Bring this line back. Oh, this line comes up to the back. Connect these, and look at what we have. We have our second layer of cubes. So if we want to track this, we would come out to 1, slide along y to 2, rise up z to 2, and I'm going to put a dot there. Put a dot right there. And with my best freehanding capabilities, that's the ordered pair of 1, 2, 2. But remember, a vector is represented as an arrow because there's direction and length. So we connect the origin to our dot. Oops. And if you find that your arrow is a little wobbly, just make the line thicker and bolder with confidence. And that is my vector x. And that is how you draw in 3 dimensions. I would encourage you to practice it. The more you practice it, the more you'll be able to see in 3 dimensions. And I think it's a tool that'll greatly help you in this class. Thanks for watching, and we're going to apply this in the next video.